Imagine a moon so mysterious, it could change everything we know about life in the universe. Europa, one of Jupiter's moons, hides a vast liquid ocean beneath its icy surface. But what's really going on beneath that frozen crust? Could there be alien life thriving in its depths? What secrets are lurking in the darkness, waiting to be uncovered? As we explore this fascinating world, we have to ask, could Europa hold the key to discovering life beyond Earth? What if the answers we've been searching for are buried under layers of ice just waiting to be found? Let's dive in. A vast subsurface ocean. Imagine a world entirely covered in ice, where beneath that thick frozen shell, an enormous, hidden ocean exists. That world is Europa, one of Jupiter's moons, and it holds secrets beneath its icy crust that could change everything we know about the possibilities of life in our solar system. This ocean, believed to be global, may be more expansive than any other body of water we know of, containing more than twice the volume of Earth's oceans combined. But here's the most mind-blowing part, it's all hidden beneath a thick layer of ice, possibly up to 25 kilometers deep. This ice acts as a shield, keeping the ocean below safe from cosmic radiation and protecting whatever might be swimming around in it from the harsh conditions of space. Scientists have speculated that if Europa's ocean could somehow be accessed, we might uncover one of the most significant discoveries in the history of space exploration. An ecosystem that has evolved in complete isolation. How crazy would it be to think that there could be alien life forms living right under our noses? No matter how advanced our technology gets, there's still so much we don't know about Europa's ocean, and we're just beginning to scratch the surface of what it could hold. Could this ocean be the perfect environment for life? Or is it just a frozen wasteland? The mystery only deepens the more we explore. Potential for life. Let's get real for a moment. What if there's life out there, not as we know it, but something radically different, thriving in the depths of Europa's ocean? That's the hope, and the theory, behind some of the most exciting research in astrobiology. For years, scientists have believed that Europa's subsurface ocean could be a perfect candidate for hosting life. It's not just about having liquid water, which is essential for life as we know it, but also the environment. Think of it, Europa's ocean is located beneath a thick ice shell, where it could be kept warm by the heat from Jupiter's powerful gravity. This heat, known as tidal heating, is what makes the ocean potentially habitable. The heat generated by Jupiter's pull keeps the ocean in a liquid state, even though it's located millions of miles away from the sun, where other water would freeze solid. But what's even more intriguing is the possibility of hydrothermal vents at the ocean's floor, similar to those found in Earth's deep oceans. On Earth, we know that life can thrive around these vents, even in complete darkness, by using chemical energy from the vents instead of sunlight. If Europa's ocean has these vents, it could create the perfect conditions for life to survive. Could life on Europa be similar to deep-sea creatures here on Earth? Or is it possible that alien life forms could be entirely different, evolving in ways we can't even imagine? The idea of alien life beneath Europa's icy shell is not just a fantasy, it's a real possibility that could reshape our understanding of life in the universe. Geological activity. Europa is far from just a cold, desolate moon drifting through space. When you take a closer look, it's clear that this icy world is far more dynamic than we could have ever imagined. The surface of Europa is covered with a network of ridges, cracks, and strange, wavy bands that make it look like the moon is constantly being reshaped. This isn't a frozen, lifeless place, it's alive with activity beneath the surface. But what's really happening on Europa? Scientists believe these surface features are the result of an active, dynamic interior. Europa's core is likely heated by tidal forces from Jupiter's immense gravity, which causes the moon's shape to subtly change over time, creating constant stress on the surface. This tidal heating is a powerful force, and it might be responsible for creating the cracks and ridges we see. But there's more. These geological features suggest that Europa's ocean might be in contact with the icy crust above it, exchanging material and energy. Imagine an exchange happening between a vast hidden ocean and the frozen surface above, an interaction that could influence the chemistry of the ocean and its potential to support life. If Europa's ocean is truly a liquid, and its ice shell is flexible, then the moon could be constantly recycling its surface, allowing for an incredible exchange of gases, minerals, and energy. Could this dynamic geological process help sustain life? It's a theory that could open the door to a whole new understanding of planetary systems and how they work. Europa is not just a frozen moon. It's a world that's still evolving and changing, and that could be crucial to its potential for supporting life. Chemical ingredients for life. When scientists think about the potential for life beyond Earth, one of the first things they consider is the presence of the right chemical ingredients. And when it comes to Europa, the moon doesn't disappoint. Research has revealed that the surface of Europa contains a wide array of essential chemicals that could be key for life to exist. One of the most important ingredients is water, and we already know that Europa has a liquid ocean beneath its icy crust. But that's just the start. Europa's surface is dotted with complex organic compounds. Those are the building blocks of life. These compounds are similar to those found in comets and asteroids, which have been known to carry the essential elements for life across the solar system. And there's more to this story. The presence of clay-like minerals on Europa's surface indicates that the moon has the kind of chemistry needed to support the formation of complex molecules. These clay minerals, rich in organic compounds, are often seen as essential for life. On Earth, we know that these minerals play a key role in helping complex molecules form, which are essential for life to thrive. And let's not forget about Europa's proximity to Jupiter. The powerful radiation from the gas giant could be helping to create more complex organic compounds by bombarding the surface with high-energy particles. This may be causing a chemical reaction on Europa's icy shell, which could further enhance the potential for life. So, when we ask what's hiding in the oceans of Europa, we're looking at a place that not only has water and energy but also the chemical building blocks for life. The stage is set. The question now is, what's hiding beneath the ice? Could we find life lurking there waiting to be discovered? Energy sources. Europa's potential to harbor life doesn't just come down to its liquid ocean or organic compounds. There's another key factor that makes this icy moon so fascinating. Energy. Energy is one of the most crucial ingredients for life, and it's not something that's just handed out in space. But on Europa, it seems like there's more than enough to keep things going. The primary source of energy on Europa is tidal heating, a result of the immense gravitational pull that Jupiter exerts on its moons. Europa's orbit isn't perfectly circular, it's slightly elliptical. This means that as it moves closer to Jupiter, the moon is subjected to immense tidal forces, causing it to stretch and flex as it orbits. Imagine the pressure of the entire moon being tugged and squeezed by the giant gas planet. This constant strain causes friction inside Europa, generating heat. This tidal heating is what keeps Europa's subsurface ocean in a liquid state, despite the freezing temperatures of the surrounding space. Without this heat, Europa's ocean would likely freeze solid, making it inhospitable for life. But because of this continuous energy input, the ocean remains liquid and potentially habitable. And what's even more intriguing is that this energy might not just support life. It could fuel the chemistry necessary for life to thrive. In the deep ocean, where sunlight doesn't reach, the heat from Europa's core could act as a sort of lifeline for any organisms that might be lurking there. So, in a way, Europa's ocean is powered by the gravitational energy of Jupiter itself, making this moon a place of incredible potential. Could this be the hidden energy source that supports alien ecosystems? The more we learn about Europa, the more it seems like the perfect place for life to exist. Upcoming missions. With so much to discover, scientists are eager to get a closer look at Europa, and the good news is that we don't have to wait much longer. One of the most anticipated missions to Europa is NASA's Europa Clipper mission, set to launch in 2024. The Europa Clipper spacecraft will be equipped with some of the most advanced technology to study the moon from every angle, including high-resolution imaging systems, spectrometers, and radar. This spacecraft will provide the most detailed pictures of Europa's icy surface, giving scientists their first real glimpse of what lies beneath the ice. One of the main objectives of the Europa Clipper mission is to study the moon's subsurface ocean, its ice shell, and how these interact with each other. By analyzing the surface and investigating potential plumes of water vapor erupting from beneath the ice, the mission could reveal signs of water and chemical processes that are essential for life. The spacecraft will fly by Europa multiple times, using its instruments to measure the composition of the ocean, determine its depth, and study the interaction between the ocean and the ice shell. The mission will also investigate whether there are any active processes, like hydrothermal vents, which could provide the energy needed for life to thrive. The Europa Clipper mission is one of the most exciting space missions of the next decade, and it could uncover critical clues about the potential for life beyond Earth. As it makes its way closer to Europa, we'll get one step closer to answering the age-old question, what's really hiding beneath the ice of this mysterious moon? The future of space exploration is about to get a lot more exciting, and Europa will be at the heart of it all. Thanks for joining us on this incredible journey to Europa. The mysteries of this icy moon could hold answers to some of the biggest questions about life beyond Earth. If you enjoyed exploring the possibilities with us, don't forget to hit that like button, share, and subscribe to Space Facts German for more mind-blowing discoveries. What do you think is hiding beneath Europa's ice? Drop your thoughts in the comments below. We'd love to hear from you. See you in the next adventure. Have you ever wondered what lies beyond our solar system? What if I told you that just 6 light-years away, there's a star system that might hold the key to understanding planets like ours? Barnard's star, the closest single star to the Sun, is hiding some fascinating secrets, and astronomers have just made a groundbreaking discovery. Could this star system be home to planets that we could one day explore? What do you think? Could life exist around a red dwarf star like Barnard's? Let's dive into this exciting discovery and uncover the mysteries together. Barnard's star system. Barnard's star, ever heard of it? This unassuming little red dwarf is not just any star, it's the closest single star to our Sun, located just a mere 6 light-years away from Earth. Now you might be thinking, 6 light-years? That sounds far, but in cosmic terms, that's practically next door. Barnard's star has been quietly orbiting the Milky Way for billions of years, yet it's only recently that it has caught the attention of astronomers hunting for exoplanets. This star isn't just another dot in the sky, it's a goldmine for discovery. Astronomers have long been curious about Barnard's star because of its proximity and relatively calm nature. While other stars might be too active, flaring up with violent eruptions, Barnard's star is a cool and stable neighbor. Over the years, scientists have pored over data, aiming to uncover hidden planets that could be lurking in its cosmic orbit. Why? Because this red dwarf star could be the key to unlocking a whole new world of possibilities. And guess what? After years of speculation and intense observation, we now know that Barnard's star isn't alone. It's hosting a mysterious planet, one that could hold the secrets to our understanding of planetary systems beyond our own. In 2024, astronomers officially confirmed the discovery of Barnard's star B, a sub-Earth mass planet that orbits its star in just over 3 Earth days. But that's not the end of the story. Stay tuned, because there's much more to this discovery than meets the eye, and we're only getting started. Discovery of Barnard's star B. Imagine a world where days pass in the blink of an eye, where a year on the planet is only 3 days long. That's exactly the situation with Barnard's star B, the newly discovered exoplanet that's orbiting its red dwarf star in a mere 3.23 days. This fascinating planet was discovered in October 2024 by astronomers using the groundbreaking espresso spectrograph on the Very Large Telescope in Chile. And let me tell you, this is one discovery that has rocked the astronomical community. What makes Barnard's star B so intriguing is not just its orbit, but its size and proximity to its host star. This planet is about half the size of Venus, making it a sub-Earth mass planet, which places it in a category that could teach us a lot about the formation of planetary systems in close proximity to their stars. With its extremely tight orbit, Barnard's star B is much closer to its star than Mercury is to the Sun, a mind-blowing 20 times closer. But here's the twist. It's too hot to support life as we know it. With an estimated surface temperature of 125 degrees Celsius, this planet is more like a sizzling oven than a potential Earth-like haven. Despite the harsh conditions, the discovery of Barnard's star B offers a tantalizing peek into the mysteries of the cosmos. As one of the closest planets to our solar system, it provides an incredible opportunity for future studies. Could this planet be the first stepping stone toward unraveling the nature of planets in the habitable zones of red dwarf stars? Only time will tell. But one thing's for sure, this discovery is only the beginning of our journey into the uncharted territory of our cosmic neighbors. Characteristics of Barnard's star B. Let's dive into the specifics of Barnard's star B. This planet is unlike anything you'll find in our solar system. First off, it's a sub-Earth mass planet, which means it's smaller than Earth, yet still larger than the smallest planets we know. Imagine a world where the days fly by at breakneck speed, Barnard's star B orbits its red dwarf star in just 3.23 Earth days. But it's not just the quick orbit that makes this planet fascinating, it's its extreme closeness to its star. At only 0.02 astronomical units from its host star, Barnard's star B is about 20 times closer than Mercury is to our Sun. This tight orbit places the planet in a sizzling environment where temperatures can soar to a sweltering 125 degrees Celsius. It's basically a cosmic furnace, and any attempt to imagine life on this world quickly evaporates under the intense heat. Liquid water? Forget about it. But while life as we know it is impossible, Barnard's star B is a goldmine for astronomers trying to piece together the mysteries of how planets form and evolve in such harsh conditions. But why does this planet matter? Well, despite the extreme heat, Barnard's star B is a great candidate for studying the behavior of planets orbiting red dwarf stars, stars that make up about 70% of the Milky Way. These types of stars are long-lived and stable, making them excellent targets for understanding the dynamics of exoplanet systems. In fact, the discovery of Barnard's star B opens the door for future studies that might reveal hidden patterns in how these planets form, survive, and interact with their host stars. So while Barnard's star B might not be the most hospitable planet, it's certainly one of the most intriguing in our cosmic neighborhood. Confirmation of additional exoplanets. Hold on tight, because Barnard's star isn't done surprising us yet. After the discovery of Barnard's star B, astronomers weren't ready to stop. In fact, their next move was to turn up the heat on their investigations. And guess what? They found more. Using the state-of-the-art Maroon X instrument on the Gemini North Telescope in Hawaii, scientists identified 3 additional exoplanet candidates orbiting Barnard's star. That's right. Barnard's star might be hosting not one but multiple sub-Earth mass planets. Each of these new planets appears to be orbiting closely to the star, just like Barnard's star B. What's really exciting about these findings is the potential for future exploration. The discovery of additional exoplanet candidates around Barnard's star gives us a rare opportunity to study a multi-planet system so close to us, something that's not common in other star systems. These newly discovered planets could share similar characteristics to Barnard's star B, or they might surprise us with their unique features, further expanding our understanding of exoplanet systems around red dwarf stars. For now, these additional planets are still in the candidate phase, meaning further observations and confirmations are needed to verify their existence. But with such advanced tools at our disposal, including high-resolution spectrometers and telescopes, the likelihood of solid confirmation is high. In the coming years, Barnard's star system might become the perfect lab for studying how planets form, evolve, and interact within a close-knit stellar family. And who knows? Maybe one of these planets holds a secret that could change the way we think about habitable worlds. The journey is just beginning. Detection methods employed. How did scientists manage to uncover Barnard's star B and its newfound planetary companions? Well, it all comes down to cutting-edge technology and a lot of patience. Astronomers have long relied on a technique called the radial velocity method to detect planets outside our solar system. This method works by measuring the subtle wobbles in a star's motion caused by the gravitational pull of orbiting planets. These wobbles may be small, but with the right tools, they reveal a lot about the planets themselves. To catch these planetary signatures, astronomers use 2 incredibly powerful instruments: the espresso spectrograph on the Very Large Telescope in Chile and the Maroon X spectrometer on the Gemini North Telescope in Hawaii. Both instruments are equipped with technology that can detect tiny shifts in a star's light, shifts that occur as planets tug on their stars in ways that are nearly invisible to the naked eye. With the help of these instruments, astronomers were able to detect the tiny gravitational influence of Barnard's star B, confirming its existence and unveiling a fascinating world that was previously hidden from us. In addition to radial velocity, astronomers are now using other innovative techniques, including direct imaging and gravitational microlensing, to observe exoplanets. As technology continues to evolve, our ability to detect and study these distant worlds will only get better, bringing us closer to understanding the true nature of the cosmos. The discovery of Barnard's star B and its companions highlights just how much we can achieve by harnessing the power of advanced telescopes and spectrographs. Who knows what other secrets these instruments will reveal in the future. Significance of the discovery. So, what does this discovery of Barnard's star B and its companions mean for us? Beyond the excitement of finding planets near our solar system, This discovery has profound implications for the study of exoplanets, particularly those orbiting red dwarf stars. Red dwarfs like Barnard's star are the most common type of star in our galaxy, and yet, we know so little about the planets that orbit them. With the confirmation of Barnard's star B and the potential for more discoveries, we are opening a window into an entirely new type of planetary system. This discovery also brings us one step closer to answering some of the most intriguing questions in astrobiology. While Barnard's star B is far too hot to support life, the close proximity of these planets to their star could provide valuable insights into the conditions that might exist on exoplanets in the habitable zone, where liquid water and life could potentially exist. In the future, astronomers may discover planets in similar systems that could harbor conditions conducive to life. Moreover, the proximity of Barnard's star, just 6 light-years away, means these planets are prime targets for future observations. With upcoming missions and next-generation telescopes like the James Webb Space Telescope, the search for life beyond our solar system is more exciting than ever. Barnard's star is just the beginning, and it's likely that we'll uncover many more exoplanet systems around nearby stars in the years to come. This discovery is a giant leap in our ongoing quest to understand the universe and our place within it. Implications for future exploration. Now here's the really exciting part. What does the discovery of Barnard's star B and its companions mean for the future of space exploration? Well, for one, Barnard's star is one of the closest stellar systems to Earth, making it a prime candidate for future interstellar missions. While we are still a long way from being able to send spacecraft to these distant stars, the potential for exploration is immense. One of the most ambitious projects to date is Breakthrough Starshot, an initiative aiming to send tiny light-powered probes to nearby star systems at a fraction of the time it would take using conventional spacecraft. These probes could reach Barnard's star in just over 20 years, providing us with invaluable data on this intriguing star system. Although the technology for such missions is still in development, the discovery of multiple planets around Barnard's star adds urgency to these efforts, as scientists now have more compelling reasons to send probes to study the system up close. In addition to these missions, the study of Barnard's star B and its companions could help us refine our understanding of exoplanet atmospheres, planetary formation, and the potential for habitable environments around red dwarf stars. As we continue to explore these planets, we could gain crucial insights into the kinds of conditions that might support life, helping us narrow down our search for habitable worlds beyond our solar system. The future of space exploration is only getting brighter, and Barnard's star system will likely play a pivotal role in that exciting journey. Thanks for joining us on this cosmic journey through the Barnard star system. Who knows what other mysteries the universe holds just beyond our reach? If you enjoyed this exploration, don't forget to like, share, and subscribe to Space Facts for more mind-blowing discoveries about our universe. We want to hear your thoughts. Could Barnard's star be home to life? Drop your comments below and let's continue the conversation. Until next time, keep looking up and stay curious about the wonders of space. Have you ever wondered what the universe is truly made of? What if everything you see around you, every star, planet, and even you, wasn't made of particles but tiny, vibrating strings? Sounds impossible, right? But string theory proposes just that. The idea that the fundamental building blocks of everything are one-dimensional strings, vibrating in ways we can barely imagine. What if this theory could explain everything, from gravity to the forces that govern atoms? In today's video, we'll dive deep into string theory and explore its mind-bending concepts. So, are you ready to unravel the mysteries of the universe? What is string theory? Imagine for a moment that the entire universe, everything you see around you, is not made of solid particles, but rather something far more mysterious. What if, at the most fundamental level, everything, from the tiniest atom to the vastest galaxy, is made up of tiny vibrating strings? That's the essence of string theory, a revolutionary idea that suggests the basic building blocks of the universe aren't particles like we've always thought, but these minuscule one-dimensional strings. Now let's break this down. Picture a guitar string vibrating. Depending on how it vibrates, it produces different notes, right? Well, according to string theory, the vibrations of these strings determine the properties of particles like quarks and electrons, particles that make up everything in the universe. These strings are unimaginably tiny, so much so that they're smaller than even atoms. And just like different vibrations on a guitar string produce different sounds, The different vibrations of these strings give rise to all the different particles and forces that govern the universe. It's a bold claim, isn't it? It challenges everything we've been taught about what makes up the fabric of reality. But what's fascinating about string theory is that it brings a fresh perspective. If we could understand how these strings vibrate, it could be the key to understanding everything. The forces that bind atoms together, the way particles interact, even the force of gravity itself, all of it could be explained by the behavior of these tiny vibrating strings. So let's journey deeper into this world of strings and see how they could change our understanding of the universe. The four fundamental forces. We all experience the world through the lens of four fundamental forces. Gravity pulls everything downward. Think of the apple falling from the tree. Electromagnetism is what makes your phone light up, or a magnet stick to your fridge. The strong nuclear force holds the nucleus of atoms together, and the weak nuclear force governs radioactive decay. But here's the thing. Even though these forces shape everything in our universe, they don't fit neatly into the same framework. Each of these forces operates on different scales, with different rules. Gravity works on large scales, holding planets and stars in place, while electromagnetism governs the behavior of charged particles like electrons. The nuclear forces, on the other hand, are confined to the tiny space within atoms. But what if they could all be part of the same system? String theory suggests exactly that. These forces may have once been unified, existing together as a single force right after the Big Bang. It's a mind-blowing thought that these forces, so different in how they act, might have all come from the same source. String theory proposes that at very high energies, like those just after the birth of the universe, these forces were united in a single, elegant force. As the universe cooled, they separated, and over billions of years evolved into the four distinct forces we observe today. But here's where it gets exciting. String theory doesn't just unify these forces, it could potentially explain why they operate the way they do. If we could understand how they evolved from 1 to 4, we could unlock answers to some of the most profound mysteries in physics. Could string theory be the key to this unification? That's the question scientists are trying to answer today. Unification of forces. Imagine this. All the forces of nature, the ones that govern everything from the tiniest particle to the largest galaxy, could at one point have been unified, existing as a single force. It sounds like science fiction, but it's a real possibility according to string theory. The idea of force unification suggests that, in the early moments of the universe, right after the Big Bang, gravity, electromagnetism, and the nuclear forces, strong and weak, were not separate entities as we know them today. Instead, they were part of a singular force that existed in harmony, working together as one. Now, picture this force like a tightly wound spring. As the universe began to cool and expand, this single force began to stretch out, cooling down and splitting into different forces over time. So gravity, which governs massive objects like planets and stars, separated from the electromagnetic force that powers electricity and magnets. Similarly, the strong nuclear force responsible for holding atomic nuclei together, and the weak nuclear force responsible for radioactive decay, broke off from each other as well. What string theory proposes is that if we can uncover how these forces were unified, we might understand not only the origins of the universe but also a deeper connection between everything that exists. All of the laws that govern the universe could have come from this one unified force. The theory also suggests that, under extreme conditions like those found inside black holes or in the first moments of the universe, these forces might merge again. If we could access that information, we could potentially create a theory of everything, unifying all the forces of nature into a single framework. Could string theory hold the key to this ultimate unification? That's the journey scientists are currently on. Extra dimensions. String theory isn't just about small strings vibrating in a big universe. It takes us beyond the familiar dimensions of space and time. You see, we are accustomed to thinking in terms of 3 dimensions of space: up, down, left, right, and forward, backward, and 1 dimension of time. But in the world of string theory, that's just the beginning. To make sense of how the theory works, we need to accept the existence of extra dimensions, dimensions beyond the ones we can see, feel, or even imagine. Now don't panic. These extra dimensions aren't something you can just walk into. In fact, string theory proposes that these extra dimensions are compactified. They're tiny and folded up in a way that makes them undetectable with our current technology. In essence, these dimensions are hidden from our everyday experience, existing at scales so small that they're invisible to even the most powerful microscopes. But why extra dimensions? Well, it turns out that these dimensions are critical for string theory to be mathematically consistent. Without them, the strings wouldn't be able to vibrate in a way that explains all the particles and forces in the universe. Some versions of string theory even propose that there could be as many as 7 extra dimensions beyond the ones we know. These dimensions might be compactified in shapes called Calabi-Yau manifolds, fancy terms for the intricate geometric shapes that these dimensions could take. But while we can't see or directly interact with these extra dimensions, they could play a huge role in how the universe operates at its most fundamental level. If we could somehow uncover more about these hidden dimensions, it might unlock some of the deepest mysteries of physics, leading us to a fuller understanding of everything that exists. Supersymmetry. Imagine a world where every particle you know, every quark, electron and photon, has a mysterious twin, a superpartner. This is where supersymmetry steps in. It's a concept within string theory that suggests that for every particle, there's a corresponding particle with different spin properties, often referred to as its superpartner. At first, it sounds a bit like science fiction, like something out of a superhero movie. But supersymmetry isn't just an intriguing idea, it's a crucial piece of the puzzle in string theory. You see, the fundamental particles we know today don't quite fit into the elegant equations that describe string theory. Enter supersymmetry, which smooths out some of these inconsistencies and helps bring string theory's predictions into alignment with reality. Now let's dive a bit deeper. Every particle in the universe has a property called spin, a fundamental characteristic that affects how the particle behaves in relation to other particles and forces. Particles like electrons, which are fermions, have half-integer spins, while force carriers like photons, the particles of light, are bosons with integer spins. According to supersymmetry, each fermion has a boson counterpart, and each boson has a fermion counterpart. This pairing helps to balance out equations and resolve some of the mathematical problems in string theory. While we haven't observed these superpartners yet because they're expected to exist only at very high energy scales, far beyond current technological capabilities, the idea of supersymmetry provides an elegant way to potentially explain some of the gaps in our understanding of the universe. If supersymmetry holds up under experimentation, it could open new doors in understanding particle physics and even the elusive concept of dark matter, the invisible substance that makes up a huge part of the universe's mass. Supersymmetry could very well be the key to unlocking mysteries we've been chasing for decades. Challenges and criticisms. As mesmerizing and elegant as string theory sounds, it's far from perfect. In fact, it faces a number of challenges and criticisms that have made many scientists hesitant to fully embrace it. And the biggest issue? The lack of experimental evidence. For any scientific theory to be accepted, it needs to be testable, something that can be observed, measured, and verified. However, string theory operates on such a small scale, far beyond what we can currently observe. The energy levels required to test the predictions of string theory are so high that even the most advanced particle accelerators, like the Large Hadron Collider, cannot reach them. This means that right now, we don't have a way to directly test whether string theory's predictions hold up in the real world. But that's not the only hurdle. Another criticism of string theory is the vast number of possible solutions it proposes. Depending on how you interpret the theory, string theory could describe an almost infinite number of possible universes, each with its own unique set of physical laws. Some critics argue that this makes string theory more of a mathematical framework than a truly predictive theory. Essentially, it's so flexible that it can explain anything. This makes it difficult to pin down a definitive prediction that could be tested. And then, there's the complexity. String theory involves highly advanced mathematics. Sometimes it feels like we're using abstract equations to describe things that we can't see or touch. For many, it feels more like an intellectual exercise than a practical theory that could be tested. Some even argue that scientists are chasing something that may never be testable, leading them away from more immediately fruitful areas of research. Despite these challenges, string theory continues to inspire physicists. The elegance and potential of unifying all forces into a single framework still resonate with many. And though we may not have all the answers now, the journey to understand the universe on its most fundamental level could take us to new frontiers of physics. Whether or not string theory becomes the ultimate theory of everything remains to be seen, But the pursuit of it is, without a doubt, an exciting chapter in the story of science. And that's a wrap on today's dive into the fascinating world of string theory. While it might seem like something straight out of science fiction, it's a theory that could change everything we know about the universe. What do you think? Could strings be the key to understanding the forces of nature? Let us know your thoughts in the comments below. If you enjoyed this journey into the unknown, don't forget to like, share, and subscribe for more amazing space facts. Until next time, keep looking up because the universe has so much more to reveal.